Hi, I'm Hugh. I'm a machine learning research engineer, and I kind of make these videos in my spare time for fun. So I made a game thing the other day, which looks kind of like uh, this. It's in Python using numpy a lot for the graphics, a little bit of OpenCV, a little bit of Pygame. And I thought it might be interesting to make a video about like how I make these graphics using numpy, because I didn't really find any documentation on the internet about that. And so maybe that could be interesting. Um, yeah, so let's start by creating something called a distance field, which is how a lot of these graphics work. Um, I've got a project here with a file called Pygame Templar. I will put this onto the internet. I mean, I basically will, oops, I will have, where are we? Mm, I will have a GitHub repo called this one, and I will add it into here. Um, so that is here. If I run this as it is, um, it should just create like a black empty display, shows the frames per second and the time to render each frame down here. So basically, that's this. Uh, so basically, we are creating a screen here. This is something so we can measure the render time. Here we've got in the while running, this is the render loop. So we start by filling the screen with blackness, and then here we flip the display, and then this is like filling the debug, like the frames per second, and then some more stuff for calculating debug and stuff for handling like execute and so on. So basically here is basically where we're going to stick rendering stuff. And then what we want to do is let's start by creating a distance field. So what we're going to do is we're going to the shading of the screen will vary with the distance from the point in the center. The further away, the darker or perhaps lighter, we'll see. And then in the center, it will be the reverse. So let's create that. So let's create a function called, I don't know, like distance shading or something like that. And so, let's not fill the whole screen. Let's like create a tile that's like 256 by 256. So have input as the tile size and the output. So we're going to output from this function a numpy array. Um, and then we'll convert that into um, a Pygame surface here. We could create this surface before the render loop and then just split it each time, which is actually that's kind of what I do in my game is I create a lot of these surfaces at the start of the game and then I just split them. But like it's a side scroller, right? Like if we go back to it, we can see it's a side scroller. So this entire background, like the entire length of the background for the entire game, I render right at the start of the game. And then I just split it on the screen at various like offsets. But for now, let's just render this real time because right. So what we're going to do is we're going to get our surface as a numpy array and whatever our method was called. Oh, we should rename this actually. Actually, we should copy this. So let's call this, I don't know, like distance field or something like that. And then let's, wait, we don't want this to be a copy. Okay, and let's, no, I guess we can revert this from here. No, we can't. Oh, did I save the wrong file? That's funny. All right, I'll sort that out later. Anyway, so what we care about is the distance field. I'll figure out the template a bit later. All right, so here we've got a method called distance shading, and we're basically just going to pass in the tile size, and we're going to set the tile size to, let's say, 256, and we could make that resolution dependent, I guess. Let's make that resolution dependent. I basically use 480 as my like default resolution and then increase things for rendering. Uh, like here, when I'm running the game here, this is just running at 480p. But when I actually render it, I will do like 1080 and render 1080p. And then the same here. I can pass in args.res and that will change the resolution. Yeah, all right. So we've got our numpy surface. Let's handle these bits here. So we need to import numpy. And so this is like a numpy typing thing I discovered recently, which is kind of handy because if you don't use that, if you could just put like mp.nd array, but then you never know what the type is. So you just have like mp.nd arrays and which are float32 and which are uint16. You have no idea. So it's pretty handy, I think, to use the new nd array typing. I don't know how new that is, but I only just discovered it recently, but it's pretty cool. All right. Now we're going to convert this. Well, let's create this then. So we'll say image is mp.zeros and it's going to be tile size by tile size, and it's going to have three colors, right? Red, green, and blue. And then the D type here was the same, mp32. So basically this is an array of numbers from 0 to 1. So like if the red value is 0, then there's no red, and if it's 1, then it's red. And we'll just return that image. So now this is a numpy array from 0 to 1. It floats, and we need to convert that into a Pygame surface. Uh, why am I calling it surface? Let's call it, I don't know, a distance field or something, distance field MP. And then we want distance field surface, which is the Pygame surface, which is what we're going to blit. So to get that, if I can actually type, we do pygame dot pixel something, pixel copy dot make surface, and then we put in the distance field MP. But this expects to get uint8, and this is uint30. This is a float32. So we need to multiply that by 255, and then do as type mp.uint8. Right, so now we've got our Pygame surface, and we can just blit that onto the screen. So screen.blit, and then we take our surface, and we have to give it a coordinate to blit, so 0, 0. There's also like special flags, which you can use for blending, but we're not going to do that just yet. So if we run this should hopefully run. It'll just be black screen. I shouldn't be running this one. I should be running this one. All right, so we've got our black screen. It's rendering. Each frame takes 1 millisecond. So basically we could get 1,000 frames per second. But it only runs at 60 because we're capping it at 60, but it could potentially run at 1,000 if we wanted it to. We're not seeing anything because we've just got a black image, right? So let's give some color to that image. So for example, we could simply make the whole image red. If we say image red, oops. The channel is red, green, blue. So channel 0 is red. So we set that to 1, then our image should be red. So we go red. Or we can say, all right, we just want the first 20 rows. Like, so this is, wait, X. First 20 columns. This is the X, this is the Y, and then this is the, so basically this is in format H, W, H, C. So W is width, H is height, and C is the color. OpenCV uses HW rather than WH, but Pygame uses WH. I find it easier just to make everything WH so that it's consistent between Pygame and my numpy stuff. And then I just convert to whatever call any OpenCV functions. All right, so the first 20 pixels are red. We could also do the same thing for the rows. We could make like the first 20 rows, say blue. Red, green, blue is, so blue is 2. So now we've got like red and blue like this. All right, so that's cool. So we're rendering numpy stuff, but like what we want to do is start doing some distance shading. So to do some distance shading, we need to have the coordinates of each point. So basically, what we want is we want an array where, so let's say we've got an array called chord, and so like 0 chord, I don't know, 150, 70 is equal, its value is 150, 70, right? Yeah, you see what I mean with that. Right, so that's our goal. Because that's not actually normally true. Like normally, like if I create an empty array, it's going to be like 0, 0, right? So if I do like IPython import numpy, if I do like, I don't know, mp.zeros, like, I don't know, like 3, 3, right? Each value is, so if I then do like, say, so if we do say a equal this, then a10 is like 0. Or if I gave that like an extra channel, let's say 2, then it's still like 0, 0. But what we want is like 1, 0 is 1, 0, and 2, 1 would be 2, 1. Right, so how do we do that? There's a very cool function called mgrid. Basically, we're going to do chord equal mgrid, and we take square brackets, not round brackets, and it's part of MP. And basically, what we can do here is, so let's just yeah, right. If we do like 0 to tile size and 0 to tile size, and then there's a transform. It's always the same transform, and I don't remember it. So let's just nab it from somewhere. This transpose. Run this transpose. All right, let's just try that down here. So if we do chord equal mp.mgrid, let's see earlier while practicing. All right, so we're going from 0 to 3, 0 to 3, and then we're running this transpose. So that gives us this chord. Now, if we look here, like chord to 1, the value is 2, 1. And the chord for 1, 2, value is 1, 2. Right, which is exactly what we want. And you'll see in a sec why we want that. All right, so I've got our coordinates. So basically, this is an array which is of size, so tile size. I guess we can call that, I don't know, t. Well, let's just call it like, let's just use the WH stuff, right? Like I'm just using tile size, but let's pretend we had height, width, and height. So basically, this is the size WH and 2. So the 2 is because we've got 2 dimensions, so each of the coordinates has 2 values, so that's the 2, it's the number of the dimensions. And then we've got 2 dimensions, WH. So basically, this number has to equal the size of the number of dimensions here. So there's 2 dimensions here and then 2. So that's the chord. Now, what we can do now is we can use the coordinate to calculate the distance from a point in the center of the screen. So the center of the tile is simply going to be like tile size divided by 2 and tile size divided by 2. And then a vector from the center to the coordinate is simply, so like let's say like delta is chord minus center. Now chord is WH2, as we said. Center we can see is simply 2. When we subtract those, because of broadcasting, the result is going to be also WH2. So we can just print delta dot shape just to show that. So there we go. So WH2. But you can't actually see which is W, which is H, because they're both tile size. But like this is W, this is H, and then this is the 2. Right. So we've got the vector from the center to the coordinate. And then what we want to do is find the length of that vector. So the length of a two-dimensional vector is basically the square root of, so let's say we've got, well, yeah. So let's say we've got a vector v, which is like, I don't know, x and y. Then the length of that vector is the square root of x squared plus y squared. But we want to vectorize this. Like we don't want to use like lots of for loops to calculate stuff. If we do that, it'd be really, really slow. Like NumPy is fast if you vectorize things, which is what we're doing. So for example, this mgrid is an example of vectorization. We're not going to like loop over for x equal, for y equal. We just got an entire NumPy array and we're just going to vectorize everything. So how do we get this length vectorized? Well, first thing we need to do is to square these things. So if we just think about, if we ignore the WH, then the delta is basically, if we just, so we're ignoring these WH, right? So I guess I can just call it like underscore delta or something like that. So the delta is like x and y in our case, right? And what we want first is, so if we do delta times delta using numpy notation, that's going to give x times x and y times y because this is a per element multiplication. All right. And then, so let's say delta times delta. This is the whole vectorized thing. Right here, I'm just writing out as if delta was just a single uh, array, like the center, like with two values. In reality, this is like three-dimensional, right? But we can do this, it's just per element multiplication. I mean, I guess we can show it down here, right? So if I do like mp.random.rand3, and then I do a times a, then basically this, if I do this times this, then that's this, right? And then this times this is this, right? Okay, so this is per element multiplication. So basically this is going to multiply all of the x values by themselves and all of the y values by themselves. Right, now what we need to do is we need to add these together. So we can add them together using np.sum. Oh, actually we can just do dot sum. And we want to add on the last axis, so axis -1. Okay, so that gives us x squared plus y squared, and then we want to square root that. So we can just do np.square root. And the result of that should be distance to center. And that should be, this should be WH. Basically, this dot sum changes it from being WH2 to being WH. Let's just print that shape just to check. So let's do print distance to center dot shape. And then let's just run that. All right, so this is the center to this like WH. All right, so okay, but what can we do that? All right, so what we can do with that is we can use, well, we were going to use that to shade, right? So let's bring down our image and we'll get rid of these bits. Well, that's true. And we can get rid of these bits. Right, so let's say that we want to shade, let's say the red channel according to the distance from the center. So we can do image, so we're taking the red channel across all of the pixels, so we're vectorizing, equals the distance to the center. Right now, we need a number from 0 to 1, but this is a number from like 0 to 200 or so, because like the whole tile is 256 by 256. So the distance to one edge is half of that, 128, but the distance to a corner from the center is going to be like the square root of 128 squared times 2. So let's just divide it by that. So we'll divide it by the square root of tile size times tile size times 2. Right now, why is it? Oh, yeah, right. So this should be a number between 0 and 1. And so basically now we should have shading according to the distance from the center. So let's just run that and check that. All right, cool. So yeah, so it's black in the center and then red around the outside. Now this distance field is super powerful. and we'll see various things that we can do that. Let's start by creating a circle. So what we can do is, instead of just shading it, well, what we can do is, if we say the distance to the center, you know what, let's just put that into a new video. So I'm just going to stop this video here and we'll see if people like it and want me to go further. And then if you like it and want me to go further, then I will continue along this line of what we can do with this distance field. And yeah, so let's do that.